Hello, hi, and welcome. And my name is Venkata Sriram, and I am an machine learning intern at Indian Servers. And today I am from Team 35 going to present the final project of my internship, facial expression detection with convolutional neural networks. So let's go how the project will work. We are going to discuss the introduction part, what are the dependencies used in this project, the data preparation, algorithms, and finally references and limitations, future implementations. So this project aims to classify the emotion on a person's face into one of these 7 categories using convolutional neural networks. The facial expression recognition software is a technology which uses the biometric markers to detect emotions in human faces. More precisely, this technology is sentiment analysis tool too and can be able to automatically detect the 6 basic universal expressions like happiness, sad, anger, surprise, fear, and disgust. So let's see our output and the result of this project. I'm going to run about my final app, and I have given the mode equal to display, which means display my project as well. It will automatically open my webcam as well, and it was showing neutral as my face detection. After smiling as happy, and I'm in normal situation, it was showing neutral. And it can able to detect multiple faces at a time, and I'm showing pictures in my mobile, and it was able to detect those pictures and those emotions also in the photograph or screen itself. So in this picture we can see about it can able to detect my original face as well as the photos and the screen faces always, and can able to detect the expressions of a person. For this project I have used the TensorFlow and OpenCV Python libraries, and for TensorFlow Keras, I'm going to build my model using convolutional neural networks, and with OpenCV, I'm going to detect the faces and using the live webcam as well. So the facial expression detection using CNN can be categorized into 4 parts, and the first part will be data pre-processing as an important phase in building my project, and the image augmentation will really increases our data set, and feature extractions made our project more accuracy after training and validation. So the data set I have taken was FER 2013, which was released by Machine Learning Conference in 2013. In this data set particularly, it was about 28,709 pictures, which was in the form of pixels. So in the data set, it contains emotion, pixels, and usage. Only these 3 columns. The emotions from 0 to 6 represents the angry, fear, happiness, sad, neutral, etc. And the list of pixel represents the particular image of a person. And the usage, there are 2 uses. One is training phase, and another one is testing phase. So the dataset contains the pictures all stored in the form of list of pixels in this dataset. We need to extract those pixels into images. So this is the code for data pre-processing, which I have to convert those pixel images into single final output pixel. In the other words, I have to convert those pixels into images, which was resized into 48 by 48 pixels. And we are using the scikit-learn's training test split for splitting the data, and the data test will be on 20% for validation, 80% will be trained. And after pre-processing data, we are going to store those particular data in the folders alignment like this. That in the data there are 2 folders. One is train and test. In the train, angry, disgust, all these 0 to 6 labels has been classified based upon the labeling technique. So this is the classification technique code which I will use to classify those images by means of their emotion signs 0 to 6. So after pre-processing the data augmentation has to be done in order to increase our project accuracy. That generally the data augmentation is applied to increase the accuracy by means of altering the images as well. This was the code for generating the data augmentation for our images, and I had used the convolutional 2D technique for fairly simple operation, and it uses a kernel which is simply called a matrix of weights. This kernel slides over the 2D input data for performing element-wise multiplication to the part of input is currently on, and then summing up the results into a single output pixels. In the dataset, we are having the list of multiple pixels of a list. So we need to convert those results into a single output pixels. Further, this convolutional 2D will help us to create that. And further, the optimizer loss function and matrices has been done. The cross entropy log loss measures the performance of classification model. At the same time, the predicted probability derives from the actual label. So predicting the probability of 0.012 when the actual observation label is 1 would be a bad result in higher loss values. So for that, the global average pooling is used to minimize the overfitting by reducing the total number of parameters in the model. Similarly, the max pooling layers, the global average pooling layers are used to reduce the spatial dimensions of the three-dimensional tensor. So I'm importing this global average pooling 2D as a part of building my model. After building my model, the validation phase can be detected by means of detecting the face and bounding a rectangular box throughout the face. And after bounding that face, we have to label the bounded box with emotion what the system has been defected. For that, I imported the Keras model, the max argument as the input. The rectangle drawn in the facial output can be given in that face. This was the JSON file which I was used to draw that rectangular box in order in capturing the webcam. So, and coming on to the performance evaluation, as we can see, the model accuracy has been increases while the epochs increases. I have performed about 50 epochs in order to increase the model accuracy. My model accuracy was about 65 to 66% accuracy on the validation set in the CNI, and the model loss can be decreased by increasing of these epochs. There is a lot of time of performing evaluation. So my model accuracy was about 65%. There are some limitations about this project. The project can able to detect multiple expression in the photographs as well as mobile screens. See, in case any security alert, the software can able to detect the screen and photos also. In that situation, there might be a limitation to that, and there is no proper user interface and the deployment for this project. And the project has only done with only 65% accuracy only. We need to improve and increase that accuracy, and the improvement of the data set also needed, as the data set contains only fewer data, about 27 images. Those was not enough to increase that model accuracy. For that limitations, in this picture depicts for that the future implementation also done in order to deployment. So for that, I'm using this more interactive with web interface and deployment. I'm decided to use the Streamlit software as a part of my web interface and deployment purpose. As in this picture, you can see that it can by applying this face mesh application using media pipe, it can able to detect the only particular live human persons only. It was by creating the frames and detecting the faces. It can able to predict the faces, not the faces in the screen itself. So by implementing this face mesh application using media pipe with the Streamlit web interface software, we can improve our model as well, and we can improve the project further. So I have applied for the Streamlit license as well for deploying my project. Soon I'm going to release the another version of this project. Thank you, Indian servers, for giving this valuable internship in order to gain some experience in machine learning and the deep learning as well. Thank you.